Now we're going to talk more about the equations of the lines other than graphing them, in addition to graphing them, right? So these, let me get my pen. These forms, these three forms we're already familiar with, right? This is the equation of a vertical line if it just has an x equals some number. K stands for constant. Okay, this is the form of a horizontal line. It's just y equals a number. And this is called the slope-intercept form. So we talked about this one last time simply because we were talking about the slope, but we didn't finish the entire equation. So when your equation is solved for y, not only is the coefficient of the x your slope, but this last term is your actual y-intercept. So it's the point 0, whatever number is here. Okay, so this is called the slope-intercept form. This is going to be our most important form. We're nearly always going to want to leave our answers in this form. Now we also have, we're going to add a new one, the point slope form, where the slope is still m, right? M always stands for slope. The slope is still m, but this time we have another point besides the y-intercept where it's just some x coordinate and y coordinate. That's what the x sub 1, y sub 1. It means, oh, this is the x value of a point on the line, and that's the corresponding y value of that point that's on the line. And then this one down here is the standard form. It's mostly just for looks, right? It's because A, B, and C can't be fractions, okay? And A can't be negative. So it just looks a little prettier. Instead of having maybe y equals negative 2/3 x plus 4, you might have an equation that's just 2x plus 3y equals 5. Everything looks all nice and sweet, okay? Notice if I'm graphing in this standard form, that's when I use my intercept method. Okay, so we're going to talk about these various forms of the equations of lines today. So first of all, let's look at the slope-intercept form. So we already mentioned the m is the slope, the b is the y-intercept. So if I want to write an equation of the line as a slope of -4 and a y-intercept that's 0, 9, I can just plug right in. Oh, and I know that's -4x, okay, plus 9. Because here's my slope. Here's the y value of the y-intercept. Okay. Now, one thing, let's back up a minute and notice these two forms I've got to memorize. Just like I had to memorize that formula for the slope, I got to memorize these. These are the two forms I'm going to use to write the equation of the line. And notice, no matter what information I'm given to actually write the equation, I need a slope and a point. 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 Now, if the point I have is the y-intercept, woohoo, I just plug it in and I'm done. But if it's not the y-intercept, I have to use this other formula. So this one was the y-intercept. I could just plug it in and I'm done. This one, the point it's given me is not the y-intercept. So I have to use the point slope formula. Okay, so y minus the y part of the point, that's what that stands for, equals m. Oh, sorry, we know what m is, so I'm going to plug in the m. M is 1/3 equals, let's try this again. Okay, yeah, there we go. So y minus the y part of the point equals m, but we know the slope, which is m, is 1/3, times x minus the x part of the point. Okay, so I just got to memorize that, just like I had to memorize the formula for the slope. And then plug in the parts that coincide. And then it says give your answer in slope-intercept form. That's nearly always how we're going to leave our answer. So if I have an equation that looks like this, the first thing I notice, I've got an equation. Get rid of the fraction, right? Get rid of the fraction. So let's multiply everything by 3, not inside parentheses, right? Not inside parentheses. That gives us 3y minus 6 equals 1 times x minus 3. Okay, let's get rid of the parentheses. X minus 3. Okay, and solve it for y, because that's the slope-intercept form when it's solved for y. So let's add 6 to both sides. Three y equals x plus 3, and divide by 3. So y equals 1/3 x plus 1. Okay, now notice that 1/3 for the slope got put right back in there, but I didn't really have to work with fractions. Okay, so I got to add those two formulas to my list along with the formula for the slope. I now have the equation in slope-intercept form and the equation in point-slope form. Okay, write an equation of the line that goes through these 2 points. Hey, didn't we just say to write the equation of the line, I need a slope and a point? I got to have a slope and a point, a slope and a point. This gave me 2 points. I need a slope and a point. Oh, well, if I have 2 points, I can find the slope. So if it doesn't give us a slope, we're going to have to find it. All right, so that's 2 minus 1. Subtracting your y's. Since I started here with my y's, I got to start here with my x's. Okay, so this is 2 plus 1 over -6, or 3 over -6, so -1/2. Okay, now I have a slope and 2 points. I can use either point I want. I just need a slope and a point. If one of the points was the y-intercept, buddy, I would use that one, and I'd just plug it in and be done. I'm going to use the one with the smaller numbers, right? So y, let me change their colors here. Might be helpful. Y minus the y part of the point equals m times x minus the x part of the point. Okay, I got a fraction again, but that's okay. I have an equation, so I'm going to multiply and get rid of the fraction, not inside parentheses. So that gives me 2y minus 4 equals -1, and I'm going to go ahead and make that x plus 2 as I'm rewriting it. Get rid of the parentheses now. 2y minus 4 equals -x minus 2. Okay, at this point, notice this one says give the answer in standard form. Most of the time, we want it in slope-intercept form, but occasionally a couple of your homework questions are going to tell you to leave it in standard form. That's really the only use we have of standard form right now. So standard form means instead of solving this thing for y, after I get rid of the fractions, because you cannot have fractions in standard form, I put the x and the y on the same side and numbers on the other. So this time, instead of solving for y, only because it says leave in standard form, I'm going to add x to both sides. So that gives me x plus 2y minus 4 equals -2, right? Because that's now gone, that's 0. And move your number to the other side. Okay, so x plus 2y equals 2. And there's the equation in standard form, only because the instructions asked me to do that. I can't have a fraction for any of my numbers, and I can't have a negative out here. If I would have wound up with a negative in front of my x, I'd have had to multiply everything by a negative and change all the signs so that my x coefficient would be positive 1, or positive whatever whole number is there. Okay, now it says write an equation of the line that goes through this point and is perpendicular to this line. Give the final answer in slope-intercept form. Yay, that's what we like. Oh, to write the equation of the line, what do I need? I need a point and a slope, a point and a slope. If it doesn't give me a slope, I have to find one. But we know what it means to be perpendicular to lines. Their slopes are negative reciprocals. So all I got to do is find the slope of this line. I'm going to solve it for y. So let's subtract 2x from both sides, which will give me 3y equals negative 2x plus 8. Let's divide by 3. That gives me y equals negative 2/3 x plus 8/3. That means the slope of this line is negative 2/3. That means the slope of the line that I want must be positive 3/2. So now, because it said perpendicular, right? So now I have a point and a slope. That's what I need. Let's plug into our formula. Y minus the y coordinate equals m times x minus the x coordinate. Okay, let's get rid of the fraction. So multiply by 2, not inside parentheses. So we have 2y minus 8 equals 3 times x plus 1. 2y minus 8 equals 3x plus 3. Move our numbers to the other side. I just want to solve that for y. 2y equals 3x plus 11, and divide by 2 to get the y all by itself. So y equals 3/2 x plus 11/2. That's the equation of the line. Goes through that point, perpendicular to this line. Okay, write an equation of the line with a slope of 2, goes through this point. Oh, I got a point and a slope, a point and a slope. I can plug in to that point slope formula. Y minus the y part of the point equals m times x minus the x part of the point. I don't have fractions this time, so let's just get rid of those parentheses and add 1 to get the y all by itself. Awesome. Okay, write an equation of the line with slope 0 that goes through this point. I hope you noticed something special, right? Okay, all this stuff goes out the window. Nope, all goes out the window. If the slope is 0, that means it's a flat line, right? It's not sloping at all. That means it's going through the y-axis. That means the equation is y equals whatever the y number is. Don't forget about those special lines, equations, graphs, slopes, special. Okay. Let's see what this does for our graphing. So if I've got an equation now that's solved for y and I'm trying to graph it, hey, I know that that's my y-intercept at the point 0, -1, and that point is right here. And I know that the slope is 2/3. This means if I go up 2 and over 3, that's another point on the line. And I can easily get 2 points. Also, if I needed an extra point, don't forget if I make them both negative, I could have went down 2 and backwards 3. Right? Or I could go up 2 and over 3 again. I could just quickly get a whole bunch of points now to draw my lines if I know the slope and a point. So that's going to be huge for us. But don't forget, now I could solve this for y and use the same concept, but don't forget if your x, y is on the same side, the intercept method's probably easier. If x is 0, this is gone, so y is -4. If y is 0, this is gone, so x is 2. So see, I didn't have to do any work. If I wanted to solve it for y, I could, but I'd had to do some algebra. So I got 2 methods now. If my x and y is on one side, the same side, think about the intercept method. If it's solved for y, though, think about that. Slope intercept method. Okay, this one is solved for y. So I know that my y-intercept is the point 0, 3, and my slope is -3/2. So 0, 3. Now, if my slope is negative, I only go negative in one direction. If they were both negative, if I did negative, negative, we just looked at that. That's the same as positive. So I can either go down 3, but positive 2, or if I want to go positive 3, I'd have to go backwards 2. Right? Make sure if your slope is negative, you only go in the negative direction one time, and you better have a line that's sloping down if your slope is negative. Okay, one more. Graph the line passing through this point with, oh look, now if I just know a point and a slope, I don't even need the equation to graph the line. I could find the equation with a point and a slope, but I don't have to find the equation to graph it. If I know my line goes through this point -2, 3, -2, 3, it's going through right there. And if it has a slope of -1/2, it means if I go down 1 and over 2, or up 1 and backwards 2, I have found another couple of points on the line. Just imagine that I drew a straight line and went through all 3 points, okay? Okay. All right, so writing the equations of a line and then also using that slope to help us graph. See you next time.